Least common multiple, or if the numbers are denominators, least common denominator. Suppose we want to add 2 over 15 to 3 over 10. The procedure in the previous section leads to 2 over 15, I multiply by 10 over 10, which is 1. I multiply by 15 over 15, which is 1. I get the same denominator. The numerator is 20. The numerator is 45. Having the same denominator, I now have bananas. I have 20 bananas plus 45 bananas, which is 65 bananas. Can I reduce? Always try to reduce fractions. That's 5 times 13. That's 3 times 5 times 10. 5 over 5 is 1. I'm left with 13 over 3 times 10, or 30. So we factored out 5 over 5, which was 1. Now I know you probably object to doing it that way, but did I do something wrong? No. The denominator 150 in this problem is larger than needs to be. The largest denominator we need is the least common multiple, or least common denominator, which is obtained by writing the prime factorization of each denominator. Divisibility tests come in handy here. Can I divide 15 by 2? No. Can I divide by 3? The sum is 6, yes. 3 times 5. Can I divide by 2? Yes. 2 times 5 is 10. Write the 15 as 3 times 5. Write the 10 as 2 times 5. But do not write different numbers in the same columns, and write as many of these factors in the same columns that you can. You have one column of 2's, one column of 3's, one column of 5's. That's 6 times 5, 30. So as many factors in the same column as possible. No different factors in the same column. No exponents. Why no exponents? Because I don't want to remember whether I need to take a number to the highest power or a factor to the lowest power. Okay? That's why I don't use exponents. Okay. So there's a whole here. It's a 2. Multiply 15 by 2 to get 30. So 2 over 2 is 1. And 4 over 30. And there's a whole here. It is 3. Multiply the 10 by 3 to get 30 also. Make it 1, 3 over 3. So 3 times 3, 9. 10 times 3, 30. You have the same denominator, 30. You can add the numerators. That's 13. Your answer is 13 over 30. The same result we had previously. Can we reduce this? 2, 3, and 5 go in the denominator. 2 and 5 don't go in the numerator. The sum is 4. You cannot divide by 3. That's in reduced form. Always try to reduce fractions without waiting to be told. Did you hear me? Always try to reduce fractions. Here's another example. Find the least common denominator of 264 and 756. You can branch this into any way that you like 4 times 66 for instance, or 2 times 132. So the 4 is not a prime number, make it 2 times 2. The 6 is not a prime number, 6 times 11. 6 is 2 times 3. So you get 2 times 2 times 2. I don't make it 2 cubed, times 3 times 11. This is 4 times 189. 4 is 2 times 2. 189, 9 times 21. 3 times 3, 7 times 3. So 264, 2 times 2 times 2 times 3 times 11. And 756, 2 times 2 times 3 times 3 times 3. 1, 2, 3 threes, and a 7. These 2 2's and these 2 2's, these 2 3's can all go in the same column. Only 2's here, only 3's here, only 7's, and only 11's here. Now we can multiply all these numbers together. Actually, I've already multiplied 2 times 2, 3 times 3 times 3 times 7, which is 756. So take 756 multiplied by 2 times 11, which is 22. Or 16,632. As a quick check, can I divide this by 756? Yes. Can I divide it by 264? Yes. were you taught to find the LCM by using sets of multiples, like finding the least common multiple of 2 and 3, set of multiples of 2, set of multiples of 3, common multiples 18, 12, 6, least common multiple 6. Now try that out with these two numbers. You get a bunch of numbers here, a bunch of numbers here. How far do you have to go in order to get, what was it, 16,632? So obviously there should be a better way, and I'll show you a better way.